Okay, we are back with this thing again. So I'm going to try again to get this to work, just because otherwise I feel like I've wasted an entire video, because if I don't get this to work, I'm not going to publish the previous one, which would be a shame. So anyway, so last night we were doing this 4011 thing, and I want to try and make a attempt at using just a single 4011, a random coin tossing circuit. And I did this one and it doesn't work. And I made a mistake here. Well, we're going to come to this. The first thing we're going to do today is looking at this part here. But this bit here, my attempt to make an oscillator was not a very good idea. Like, I wanted to do this because I really wanted to have the minimum number of components, and I thought it doesn't matter how fast it's doing it because you're just trying to pick it at any point, and it should be neither on or off. Though I was going to go through afterwards and see if there's if it's 50-50 chance, or if in fact you tend to get one of them over the other one, which I think you might. But the problem, I think, like, I don't know why it doesn't work, but I'm going to guess you have to start thinking about the propagation delays within the IC when you do this kind of thing. And so when you've got the inputs here, the time between the inputs and the output changing is like isn't instantaneous. There is like a small amount of time before this actually happens, and it's just because of physics and how these things are made up, and it will be different for each IC, I guess, and due to manufacturing bits and pieces. But we can assume that it's roughly the same across the whole IC, which causes a problem, which might be the reason that it doesn't work. Sorry, I'm going to move that out of the way. So that's going to come into, I'm going to show you what that does in a second. But my idea is that, well, okay, so today this is a high voltage here, and so there's a high on this line here. Forget the pull up or pull down resistors for a second. And there's a high here, and then it's going through here to become a low. But that's not really going to work, because it's going to go through here, and then it's got to have a time period. So we're going to say, we'll call that T. To get through here. This is the T time to propagate. I think that's the TP. Time to propagate through here. And then, so if this was high and then it becomes low, you have to wait this tiny amount of time before it propagates through to the other side. Like, it's a nanoseconds, right? It's a small amount of time. And then it pops out the other side and it changes the output. But during this time, the output is still, so this becomes high, the output is still high until it's propagated, the change is propagated through the gate and come out here. And the problem is, of course, is that that's not in line with this one here, because this one's not being inverted. So this is what's coming out of here. So if this is high, so we can assume that this starts off being low, so this becomes high, and then you've got the time to propagate here between it going, so this is low, so at the moment, when this one becomes high, this is already high, right? So it's high from the last oscillation, and then it goes here, it becomes high, and then the output will become low, but only after this propagation time. But that propagation time is pretty much the same as for this one here. So after the time, so by the time that the low voltage or the high voltage gets from here to here and becomes the low out this side, this would have changed to a low voltage. And so the effect would be, if this is like a more accurate reflection of what's coming out of this gate, and this has got a delay coming out of this gate, which is the same as the delay that this one changes over, it's actually going to end up being the same output. So they're always going to be high or low or whatever. So it won't be exactly right. They'll be like moving around, but it won't be really what I want. And maybe that's why it doesn't work. But then it's interesting that when you put the pull-ups in, it changes the behavior. But I've gone and done it. I've got these pull-ups, right? So anyway, I've gone and got rid of this oscillator section. So we've still got this inverter here. I'm still using the inverter, and I've still got the RS. Like, I need the latch so that I can pause it. I'm going to come back to this. Maybe like the oscillators look like where you could stop the oscillator at any point and then take the output, but you have to store it somewhere. That's what this thing is here. So we need this part. We might not need this in the end, but for now we do. So this is one of those little 555 timer boards. So we're going to use this to do the oscillating. So when I turn it on, it's now flipping between these two states. So this is coming out, and because this is essentially changing much slower than the propagation delay, then it's going to work fine here. So there's going to be an instant, it doesn't matter so much. This takes a very small amount of time to propagate the change through, because most of the time it's going to be in a stable state in comparison. So it's changing real fast, but it's not. I want it to change super fast. I don't want to actually see it flickering. So hopefully we can get it to oscillate at much higher speed. But that's not the point. The first thing I want to do is I want to do the trick where if I press the button down, which we haven't done yet, then they will stop in one of the two states. And then we're going to come back and look at how to redo this section, still using the 4011, but with a better oscillator design instead of this rubbishy way of doing it, which doesn't really work. So we'll try and do this. So I thought, because what I have here is I wanted to have a button, so you can actually do this straight off. This is going to be my little button here. I don't know why I've put it quite there. It's going to have to be... I'm running out of... Oh, that's right. What I was going to do is I was going to move this to here. So the bad thing about these is that they don't really... They waste a bit of real estate. But that's... Okay, I'm going to put it... There's a bit cramped there. So... okay. We'll have to put it over the middle. Alright, it's not touching the lines with the LEDs. And so this, where did I put that little tiny thing? Alright, this one is going to go to ground. So one of these legs is going to ground. And that's the easy part. We can turn it off for a second. So this one's not going to work. Yeah, so I want to pull the inputs to this latch to ground, and that gives you the stable output. So as we did from the last video. But I just ridiculously done this yesterday where I had the ground pulled to both of these wires. So I've attached the button to the input to this part of the latch, and so to the R and the S inputs on the latch. But of course that just links the latch together. So what will happen is this is a positive voltage, you'll get a positive voltage here, and this is a positive. So you always get a positive voltage, or you'll always get like halfway through and it just won't work. Because I've basically short-circuited it across there. But I'm figuring if I use something clever with some two diodes, it might just work. So here's my little diodes, and I've actually lined it up wrong. Yay! So we still want it to pull down to ground, but I should have drawn this a better. So because really I have no idea what I'm doing because I haven't really thought it out. So this is the input to that thing, and then it's going as an input into the inverter, and then that one's going to there. So these are the 2 points that I want to pull down. So I want the diode. I've actually completely forgotten which way around they go. That's pretty bad. Well, I assume the line goes to negative, right? So I want the line to go to negative. So let's see if I can just quickly draw the circuit here. So here is input 1, here is input 2. There's the pull-up. So that's R and that's S. It doesn't matter. One of those two things there. So these are these two inputs here. And then I'm going to, how am I going to do this? I'm going to have diode going to there, and that's going to ground. And then I've got another diode. We're going to jump over that wire. And that one is going to be connected to there. And so when I and there's the button's going in there. So you can't see it, but that's the little button there. So there's my little button. So that's not actually linked. So when I press this, there will be a connection to the ground. This will be pulled to ground along here. So I know it looks like the arrow is going the other way. It's just why it's kind of funky, because the arrow is going the other way. But that's just going in the direction of the current, in a sense. And so I'm saying, well, there's a lower voltage here than will be here. I'm just making sure that it's being pulled to ground. So that's the way it should go, I think. And this one here, but if this was, say, a high voltage, well, it can't affect this thing here because it can't go through that. It can't go in that direction through the diode. So that should work. So that should, I think, work. It always feels like in all these things, when you get confused about, this is what I always find, which I'm getting much better at, which is, you know, you think about, people are always saying you should think about flowing electricity, or a water analogy, but quite often I think it, like when you start off, it makes you kind of end up making these kind of mistakes because you're thinking about, well, it's going to flow through here and into here, but then you don't think about the fact that it's doing this. At least that's what I have found. So anyway, can I do, so I think it goes this way. I'm just going to put it into this line. So that's the input to there, and it will reach. I don't think it's going to be a very good idea to do it like that. So especially when, okay, this one's going to need a bit of creativity to get it all the way across. So that's way too far away from the button. So it's going to need a little bit of an extra wire. So this wire is going to go to here. So the idea is that when I run it now, when I turn it on, nothing will change. It should be flickering, but when I press the button, it should stop on one of them. So let's just see what happens. Nope. It's the wrong way around. Alright, so maybe I've just half asleep, and so I'm just going to flip that one around. And then I'm going to flip that one around. Because I've kind of gotten away everything works. I've got a cold at the moment, so I can't really think about things, and my brain's like, I'm not going to think about things. And I really want this to work, so oh, that didn't do anything. Alright, well that would be if it was facing that way. No, if it was doing that. Oh, well this isn't going to work either. Wait, I did pull it to ground. So, alright. Yes, I think this is the way. Well, that's interesting. That's very interesting. Alright. What if, just for the fun of it, that's not going to work either, is it? If I pull it high, that doesn't do anything. Well, why doesn't that work? So have I got it? Oh, I think I might know why. No. That's going into the input. And that's going into the input. So I've done this quite differently, haven't I? So that's the inverter output. And I might just give up on this whole project because it's just me wasting my time making these videos that I'm never going to post. Oh, that was a bad idea. Let's just see. So when I press that down, why does it go? Where's my little multimeter? Oh, well that didn't sound good. Alright, so I'm going to turn this on. I feel like I need one with the clippy cables because this is going to be a mess. Because I'm going to have to hold these in place and press. So where's ground? There's a ground. Alright, and where is my output? Okay, I can do this. So it says 0.2. Well, okay. That's exactly what you would expect it to be. Alright, so that's what I want, because it's going to pull it down to that, but there's going to be a voltage drop across the... How's that working? I guess. Alright, well, I'm going to stop the video here. I'm actually going to try and work this thing out before I post any more videos. So thanks for watching. Bye.